Hey everyone, Shannon from YSIP here. In this video, we're going to test the method that we used in the last one where we determined the diameter of a star. And we're going to do it experimentally using a shoe, a ruler, a piece of string, not my hoodie string, and a calculator. And so you can follow along, and I want to see your results in the comments when we're done. So keep watching and we'll learn how to do that. So yeah, you'll just need those things that I just mentioned. And let's do some science. All right, so this is the part of the video where the shoe comes in. And why does it come in? Because we're gonna go outside and take some measurements to find out if this formula that I use to measure the diameter of a star is accurate in measuring the diameter of a tree. And so we're gonna take two measurements. One's gonna help us find the experimental value, and one's gonna help us find our expected value. And our expected value is just a measurement with a high degree of accuracy. And to get this one, what we're gonna do is use a string wrapped around the trunk of the tree to find its circumference, divide that by pi, and that's gonna equal the diameter because that's the ratio of how circles work. We know that from math. And experimentally, what we're going to do is we're gonna use the trick that our thumb, when it's outstretched, takes up 2 degrees of angular diameter. So we're going to walk forwards and backwards until the tree we chose is the same width as our thumb. What that means is that our angular diameter is going to be 2 degrees, and our distance, our R value, is just going to be the number of heel-to-toe steps it takes to get from that point all the way over to the tree. So we're going to compare those two values, see what they agree with each other. I want you to watch these next clips real close and then try it for yourself, okay? So you can keep watching. All right, there I am at the university, and what I've done is I've chosen a tree, and when I stick my thumb out at an arm's length away and close one eye, I want my thumb and the tree to be the same width. And if my thumb is too big, I want to take steps towards the tree, and if my thumb is too small, I want to take steps back. So once you found the spot where the tree looks like it's the same width as your thumb, when you close one eye and stick out your thumb, what you're going to do is you're going to take steps heel to toe all the way over to the tree and count the number of steps it takes you and then write that number down. Okay, so now what we're going to do is take our string and wrap it all the way around the tree. And what we're going to do is mark where the string meets back up with itself. Okay? For me, that is this length. So what I'm going to do is just go ahead and cut the string, and that way I know the circumference of my tree. And we're going to use this measurement to determine our expected value, okay? So there we go, and we can head back inside. All right, so now it's your turn. First things first, get the go-ahead to go outside. Then grab a string that's as long as your arms and get something to mark it or cut it, and then something to write down the number of steps it takes you to get to your tree, okay? So pause this video, go and take those measurements, and then come back in and we'll crunch some numbers, okay? All right, so we have our measurements. Let's find out what our expected value is. So it's just equal to the circumference, the length of the string divided by pi. So my is 220 centimeters over pi. And what I got was 70.0 centimeters. And what did I get from my experimental value? Well, what we need to do is do a little bit more work here for the distance, but not much. What we're going to do is 2 pi times 2 degrees for our angular diameter because of the thumb trick, multiplied by the number of steps we took and how big they are. So in my case, I took 67 steps, and my steps are each 30 centimeters long. And then we divide all of that by 360 degrees. And the number I got from this was 70.2 centimeters. Okay, 70 centimeters and 70.2 centimeters. That's awesome. That's really close. And so that's something we do a lot in science, is where, you know, when we use that formula, we never actually had to touch the tree to do it. We only ever touched the tree with our string to get an expected value. And so that's a great way that we can, you know, extend ideas. So we know that it works here. So we know it works at interstellar distances. And that's science. It's taking simple things and applying them to big things. And that's the video. Leave your results, the experimental and the expected values, in the comments. Like, subscribe, share it with your friends, and I'll see you later.